In this last video, I'm going to do one example with you. And this is sort of the ultimate example. If you can do this set of problems without having to look at anything and you just kind of work your way through them and get the right answer, you're in great shape, because this is the ultimate goal of this lesson, is that you can do problems like number 54. In the directions for 54, we are told to find all the real zeros, find exact values wherever possible, identify each answer as rational or irrational. Well, we start off by listing our candidates for zeros. And I'm not going to write the left side that I've been writing on the previous examples, and you can leave that out when you're comfortable doing so. But remember that on the top, we list, sorry about that, the factors of the constant term, which in this case is 10. So plus or minus 1, which would match up with plus or minus 10. And then plus or minus 2, which would match up with plus or minus 5. And that's all of them. So then we go to the leading coefficient, which is 1, which is really cool because that means it's just plus or minus 1, which means that the numerator is our list of candidates. So our candidates are actually plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. And any time the leading coefficient is 1, if you're comfortable doing it, once you get comfortable with all this, you can just list these guys and not worry about writing the quotient version that I wrote first. All right, so now we have a list of technically 8 zeros to look at. But since this is a calculator question, I would recommend that you graph this to where you can see the zeros. And I've done that, and I'm going to insert the graph here for you. And if you want to pause the video and play with your calculator and see if our pictures look alike, that's fine. Or if you just want to run through the video, that's fine too. Hang with me for just one sec. So here you see the graph. And what we want to do is look for things in this graph that, or on this picture, that are pretty exact values. And if you look, I see one right there that I like. Let me see if I can do that without marking over it. There we go. That's crossing a mark that stands for an integer value of -1, because we are counting by 0.5 here as our scale. And really that's all I need to start, okay? But it looks like maybe 2 works over here, but without zooming in further and investigating that closer, that's kind of a guess. So I would start with the -1 if I were you. So let's do that. We're going to start with -1. And our coefficients are 1, -1, -7, 5, and 10. And always make sure that you don't need to put a 0 in. And since our degree goes 4, 3, 2, 1, 0, we are good and don't need one. But don't forget that, because it's easy to fall into the trap of not doing it when we don't have a bunch of examples that have zeros in them. So I'm going to bring my 1 down, multiply up, add, multiply up, subtract because the signs are different, or add, however you want to think about it. Multiply up, you get 5, which is 10. Multiply up, you get -10, which gives us 0, which assures us that, in fact, -1 is a 0. Now, if you do this, even though the wording of this problem might tell you this is unnecessary, this will make this sort of like automatic. So what we should do is rewrite our f of x based on what we know so far, which is that -1 is a 0, so that means it has a factor of x plus 1, and then I'm going to translate this bottom row into a quadratic because into a cubic, because we were dividing a quartic by a linear. So this is x cubed minus 2x squared minus 5x plus 10. Barely left myself room there. All right, so now that we're going to try the 2 that looked like a candidate, but we weren't really sure, so let's find out. So now we're going to run over here and look at 2. But we're not going all the way back to the original quartic. We're going to use the cubic that we got from what we just wrote. So we're going to have 1, -2, -5, and +10. Put our bar, 1 down, multiply up, we get 0. Multiply up, we get 0. Multiply up, we get -10, which confirms that what looked like a 2 actually was a 2. So now we know that we have f of x equals, and I would write, if I were writing down a sheet of notebook paper, I would put that synthetic we just did right below and then put what I'm about to write below that. But this works out okay for this example to do it this way. So we've got x plus 1 from the first run. Well, now we just verified that x minus 2 is a factor, and we translate that 1, 0, negative 5 into a quadratic result. So that's x squared, and then that would be plus 0x for that 0, so it's minus 5. Well, now, this is a really cool example, and it's one of the reasons I like this problem, is that we don't need to do anything else. We already know what our zeros are going to be, because this difference of two squares, and you're saying 5 is not a square, Miss Twitty, are you crazy? And I'm about to show you that we can treat any number as a square. So this is x plus 1 times x minus 2, and then this, if I treat this as a difference of two squares, it's x minus the square root of 5 and x plus the square root of 5. So that would give us as zeros that x equals 1, negative 2, and plus or minus the square root of 5. How cool is that? We just found our zeros. Now we are, for our answer purposes, to state which ones are which, and hopefully it's pretty obvious that in the list of negative 1, 2, and plus or minus the square root of 5, that these two are our rational ones. And if you'll recall, those are the ones that showed up in our list. Clearly we didn't have any square roots in our list of candidates, and the square root is irrational. And that technically meets the requirements, but I want to show you one more thing before we close out. And a little side note here, the square root of 5 is approximately 2.236. And so now I want to show you a picture I did on my calculator where I had it flag the zeros, and I saved them as I went and took a picture of it. And here it is. And look at what we have. Confirmation that our process worked, because the 2.24 is the 2.236 rounded. So here's the negative square root of 5. Here's negative 1. Here's positive 2. And here is the positive square root of 5. And that's what you should do on this set, is confirm your answers using your calculator after you've computed it. And as always, if you have questions, holla back. That's the end of the video.